So chapter 4 is all about aqueous solutions. One of the things that we are going to dedicate working a couple labs this quarter is looking at precipitation reactions. So a precipitation reaction, this is one that's going to produce a solid from two aqueous reactants. So when we mix two solutions together, we're going to get a solid. It's going to be insoluble. We call this solid the precipitate, and we shorthand this PPT, and sometimes it's put in parentheses, and instead of using the S symbol, so instead of doing this, sometimes you'll see it abbreviated just PPT to indicate that it truly is a precipitate and not just a solid that was started with. So they mean the same thing, but this is much more specific. Essentially what a precipitate is an insoluble compound in water. Okay, so it forms a solid when in water. Our solubility rules, these are going to predict whether or not a compound is soluble or not in water. So I have solubility rules in here in quotations because these aren't true rules. They're more like guidelines. Okay? They're not right 100% of the time, and in some situations they could be wrong, but for the most part they are true. Okay? With these solubility rules, another thing to keep in mind is the reason why we have them is because there is no rhyme or reason as to why one salt will dissolve in water and another salt will not. Okay, so we really do just have these rules, and this is what we follow. You do not need to memorize these rules. And these are the rules here. This is from your book. However, I do have a suggestion that it is helpful to know that there are 3 ions that are always soluble. We have sodium ions, potassium ions, and nitrate. It doesn't matter what these 3 are paired with, they are always soluble in water. If you remember those 3, you have answered probably a majority of the questions that I can ask about solubility rules. All right, so let's do an example of looking at a reaction and the different equations or the different representations we can write out for a precipitation reaction. So this is an example. And essentially we're looking at 3 different components. So these all work under the same example. So first, we want to predict the products of a reaction between barium chloride, which is aqueous, meaning it's in water, and sodium sulfate, also aqueous, so in water. This is called a double displacement reaction. So what's going to happen is we have an ionic compound here, so a positive and a negative. We have another ionic compound, a positive with a negative. Remember, SO4 is a polyatomic ion, so this as a whole is negative. So what's going to happen if a reaction's going to occur, the only thing that they can do is swap partners. So the positive here of barium is going to go with the negative in the sodium sulfate. And then our positive from sodium sulfate goes with the negative of barium chloride. Okay, so they're just going to swap partners, and remember, our positive ion or cation is listed first. So we want to look at how these split apart. So we have the barium ion is 2+, and it's going to combine with the sulfate, which is SO4, 2-. So in these two combine, we have BaSO4. Then with our sodium and our chloride, sodium is a +1, chloride is a -1. So in these two combine, we have NaCl. Notice that I've ignored the fact that we have a subscript of 2 for sodium and 2 for chloride here. Okay, I ignore those subscripts because to write the formula between these two ions, all we need to know are the charges. Okay, we will balance the fact that we have 2 of each of these in our equations down below by using our coefficients. All right, so we have the formulas of our products in our reaction. Now we need to figure out our phases. Okay? In other words, is something soluble or not? If something is soluble, this means that it's going to be aqueous. It's going to be able to be in the water. If something is insoluble, this means that we're going to form a precipitate. It's going to form a solid. So if we look at barium sulfate, generally you're going to look at just one ion at a time up here in the table. So we notice here we have sulfates, SO4, 2-. These are soluble except when they are combined with silver, calcium ion, strontium ion, barium, this is a mercury complex, or lead 2+. So we have barium over here, which means that barium sulfate is insoluble. So this is going to form a solid, or our precipitate. Sodium chloride over here, this is soluble, so it's aqueous. 2 ways to know that. One is sodium, so it's always soluble. Or if we look up here in our table, we have all sodiums. Anything containing sodium is going to be soluble. And if we look under chloride, we're lucky in this case that we have both ions on this table. If we look up at chloride, everything's soluble except when silver, mercury, or lead 2 are included. It's not one of those 3, so it has to be soluble. So again, barium sulfate is insoluble. It's one of our insoluble exceptions for sulfates, so it's going to form a solid, and that's our precipitate. Sodium chloride has sodium in it, so we have aqueous. For our molecular equation, I will go ahead and describe these 3 equations here in the next video.